Hello everyone, welcome back to Chemistry Chronicles. This is part 2 of our physical chemistry lessons. Today we will learn about the first law of thermodynamics. According to the first law of thermodynamics, the change in internal energy is equal to heat plus the work done. Note that internal energy of an isolated system is always constant, and since it is a state function, regardless of the path, it remains the same. But yes, the direction will definitely change the sign. Both heat and work are path functions, and they are positive if heat is absorbed by the system and work is done on the system. There are two variations in work done. The first one is work done due to expansion. Here, pressure is constant. The other one is work done of an isothermal reversible system, and in this case, temperature is constant. This only occurs for perfect gases, also known as ideal gases, and the R value we will use this time is 8.314. Next up, we have heat. We can use this formula to find out heat. From the formula, you can notice that heat follows the change in temperature, which means the change in temperature can affect the value of heat. C in this case is calorimeter constant, which is also known as heat capacitance. There are two variations of C, Cp and Cv. Cp is used when pressure is constant and Cv is used when volume is constant. We can also write them as Cpm or Cvm, which is basically molar capacitance. Cvs and Cps are specific heat capacitance. They both have different units. But to find heat, we will use the molar heat capacitance depending on what is constant. But remember that we can only use these formulas if our C is constant. If our Cpm or Cvm is not constant, then there is another formula to find the C. This is the formula, and here A, B and C are imperial parameters, and they will be provided to you by your instructor. Cp is always considered greater than Cv. But why? It is because for Cv, the system is kept at a constant volume. That means there is no work done on the system as heat is added. All the heat that is added increases the temperature of the system. But when pressure is constant, work is done on the system in the form of expansion. In this case, volume is not constant. So some heat is required to do the work. That is why Cp is greater than Cv. There is a direct relationship between Cp and Cv. We can find the values of Cp and Cp using this equation, where Cp minus Cv is equal to Nr. These are some questions for you to solve. I will solve these in the next video. Take care. Bye-bye.